Okay, good morning, everyone. Welcome back to a new session, Computer Science 2, CS2 514 for LTU Summer 2022. Today we are at week 3A, Intro to Classes. So as usual, I have the book in front of me. Be mindful that test 1 is this week. I sent an announcement via Canvas, via email about test 1. It's gonna be online, so I'm gonna submit today or tomorrow the test, and you're gonna have 48 hours to do it. It's gonna be available for 48 hours, and once you start your test, you have 2 hours to submit. You cannot pause. So please make sure to dedicate 2 hours without the internet connection interruption or anything like that. And good luck. Let me know if you need any help. So introduction to classes. I'm gonna go the same way the book does it. So let me open Visual Studio in case we need to start with the coding. So introduction to classes, chapter 13. First topic, they start by saying procedural and object-oriented programming. What the book is trying to tell you here is there was a method of writing code, which was the procedural programming, which is whatever you learned so far. Methods or functions receiving input data, doing some tasks, and then returning some result. That was procedural programming, basically, or briefly. It was methods, and everything revolved around methods, and methods communicated with each other. On the other hand, object-oriented programming, everything revolved around objects. Objects are created from abstract data types that encapsulate data and functions together, and user defined. User in this context is programmer defined. So the programmer defines a abstract data type, and then you create, as a programmer, you create instances from the abstract data type or from that class. So as I mentioned, up to this chapter, you have learned to write procedural programming. There are some specifications to object-oriented programming. One thing, or there are 4 in total. Let me share some knowledge with you. In case you go and you have an interview for a job, they might ask you, okay, what's object-oriented programming? OOP. If you answer using these 4 terms and explaining each term, of course, you would be good to go. So you have 4 main features under object-oriented programming. One thing is encapsulation. Second is data hiding. Not in a specific order. Data hiding. Third would be inheritance. Inheritance. And last would be called polymorphism. These are the main or the 4 features of object-oriented programming. Encapsulation means inside your object. Sorry, hold on. Okay. So inside the object, encapsulation means we have data and then we have methods that operate on the data. So we're gonna have some object. Inside that object, we have encapsulated together data related to that object. And also you have data and you have methods or functions. Methods that operate on that data. So this is my object, it's a square, and encapsulated in it, section for the data, section for the methods that operate on that data. For example, The book gives a good example about a rectangle. A rectangle has width and has height, and those are the data value. So the data is stored inside variables, variable for width, variable for height. Then I have a method that's called, for example, compute area. And this returns the area of the rectangle. So this method inside my object operates on the data inside object. So compute from the outside world, everything outside the object communicates through methods, communicates and accesses the data through the methods. So some outside code will call compute area. Compute area will operate on the data, doing its task, and then finally returning to the outside world the area, the task, or the result. So this is what was meant by encapsulation. Encapsulation means method and data encapsulated in one object, unlike procedural programming where data is for all methods. Then we have data hiding. Data hiding means inside my object, whether it's data or methods, I have two sections. I have a private section, and then I have a public section. Inside the private, I might have data plus methods. Some methods are private. Some data is private. Also, here in the public section, I might have data plus methods. Some data are public to the outside world. Some methods are public to the outside world. So this is what was meant by data hiding. Then we have inheritance. Inheritance means we can reuse the code instead of reinventing the wheel. So inheritance means I might have a class, and then I can inherit from this class to create a new class that has everything from class 1 in addition to new stuff. So when I inherit from a class, I could basically create a new class that has everything from its parent plus the stuff that I add, plus data, plus methods that the programmer adds. For example, take a living creature, living thing. Every living thing, for example, has a data, let's say age period or age. Every living thing has a data for age stored in a variable. As simple as that for now. Living thing has an age. Under living thing, inherited from living thing, we have plants, we have human, we have animals. So plants have different stuff than a human, and the plants have extra stuff on living thing. So living thing has age. Plant, for example, let's say has a color. Maybe everything has a color. What would be specific to plants? Let's say a human has a job. Animals have something different than a human. I don't know. Let's say a high speed rate. Anyway, the idea is animals have whatever is in living thing plus additional stuff. Also human has whatever in living thing plus stuff. So this inheritance topic or inheritance feature allows the programmer to reuse a code. So all the data and the methods that were written in living thing, I can inherit from them and add to them instead of rewriting everything from scratch. So I can reuse stuff. Then we have polymorphism. Polymorphism is a calling. So when you have inheritance, polymorphism related to inheritance, you cannot have polymorphism without inheritance. So for example, I can have a method called move. Living thing will have move. Animal will have move. Human have move. Plants do not have move. They cannot move. So when I call move, polymorphism means when I call a function called move that exists in the tree top to bottom, when I call move, the specific to the object in question will be called. So since I have move everywhere, that's the basic idea or the brief idea really quick, because this is not our concern today. But an idea, move, polymorphism means when I call a function that exists in all objects, the specific object will be called, only the specific object. We'll see it in future in details. So this is object-oriented programming. Then we go by the book. They still talk about procedural programming has worked well for software developers for many years. However, as programs become larger and more complex, the separation of a program's data and the code that operates on the data can lead to problems. So imagine you have this structure, main, function prototypes above, function definitions below, and you have a very, very big program. It gets complicated and dirty really quick. So classes and object. What is a class and what's an object? A class is the blueprint of the object. So remember, for example, the book gives a good example about describing the house. You know how you have a blueprint, right? You hire a graphic designer or civil engineer or whatever, and they draw a blueprint for you. They say, okay, this is the house plan. This is how the living room is. And then this is the bathroom. This is living room. This is another room. This is the stairs, etc. So it's a blueprint. Stairs to upstairs or basement, whatever. So a class is the blueprint. The object is the houses built based on that blueprint. Out of the same blueprint, I can create many houses and they are all gonna be the same because the houses were defined by the blueprint. So this is the abstract data type, and then I go and build the house based on it. This is house one. It matches the blueprint. Inside has this, has that. I create one instance of that blueprint. So the object was an instance of that class. I can create one, I can create two, I can create three, I can create as many as I want. And every house out of these houses has its own copy of the stuff, right? The door here is a copy, different door. They don't share the same door. They don't share the same data. They don't share the same methods. Every instance has its own data, own methods based on the blueprint. The blueprint defines what is and what's not, and then we create instances from that class. Same here, I can create the same house again and again. Then we go to a reminder that you already used a class before or an instance of class, and that was the string class. You know how we use the string class? You included the definition, the blueprint, and then you create an instance from that class. You say, I need an object, the type is string, the name is str, semicolon. Then you start operating on that uh, object. So you start assigning it value, for example. You start calling, for example, auto al length equals lstr dot length, right? So this method is a method inside the class string that operates on the data inside the string. I created an instance of that string. I gave it some data, and then it has, not me, I didn't write length. The object string or the class string has a method encapsulated in it that operates on the data. In this case, length, it will count how many characters are in this string and return to the outside word, because main is an outsider with respect to string. String class is encapsulated. It has in it data and methods, and main is the outside word. Main created an instance of that class, gave it some data, accessed its capsule and put data in it, and then it started calling methods that are provided to the public, provided to the outsiders. For example, length is a public. The fact that main can call or can see length, that means length is a public method. So the book is trying to say that, hey, you already used the class before. So remember when you did this and that, this is similar idea when it comes to classes. But in this case, today we're gonna learn how to write our own class and then create instances from it. So introduction to classes, topic 13.2. In C++, the class is the construct primarily used to create objects. So for example, I'm gonna go here. The format is, the format as a format, you say I need class, and then you give it class name. Then you open parentheses, remember the semicolon. Then you say, okay, I need a private section, I need a public section, and it doesn't matter which one comes first. You can put private first, public last. I need a private section, I need a public section, and then you start adding your data. For example, I need int whatever, char whatever. I need a public int. I need a private some method. I need a public method, etc. So this is the basic structure of a class. In this case, they used rectangle, so I'm going to do the same exact example. So any rectangle, class rectangle, will have, as I mentioned, private section, public section. Under the private section, we're going to have width. And in my standard, everything that is member variable, I started with an M. This width variable is a member variable to the class rectangle. Double M height. In the public section, I'm going to have what's called access specifiers. So I'm going to have a set width, and set width takes a double a width. I have set height, and it takes double height. Then I have get width, and this should return a double get height. Then double get area. So set width is void, and this guy is void. And then I'm gonna add the word const here. Const. So this is my simple, humble class. It has a name. It has access specifiers, means specifying the access level. Is it private or public? So these two, private and public, are called access specifiers. Under private, I have two variables, one for width, one for height. Under public, I have 5 methods, 2 for setting those variables, 2 for getting those variables. So one is in, one is out, and one for get area. The word const here, the one that you see after the function name, const means, hey function, you are not allowed to change any data. So by me adding const, I'm protecting myself from myself. Eventually, you're gonna realize at some point that you are the user of your code. You're gonna write code and then you're gonna get back to it and back to it and back to it. So basically, you are the user of your own code. So you gonna be protecting yourself from your future self, from you when you come back later and add to the code or use the code or debug the code. So const tells this method that if this method changes the data in any way, the compiler will generate an error. So by telling it const, I'm protecting myself that anything I do here, I should not change the data in my class. Get width has only one job, right? It has a job to get or to return the width from the private section to the outside world. It's not allowed, or it's not its responsibility to change or modify the value. We should not allow getters. So these are setters and these are getters. We should not allow getters to change the data in any way. So this just to protect myself. Then we're gonna go ahead and define the member functions. So basically, these are prototypes. You see how they look like a prototype? I could have removed, omitted these names. So these are prototypes. Now I need to provide their functionality or their body. And this happens outside. We go ahead and we say, so this is one scope, this is another scope. At that level, at the same level with the class, I can say, hey, compiler, I need to define a void method, and it is related to the rectangle class, colon, set width. It takes a double A width. Notice this is similar that you did before, where you define or provide the body under main. We could have done it under main, but that's not our concern for now. But look at the format. Void the class rectangle colon. So I'm defining a method that is for rectangle, not just any method. I'm defining the method of the rectangle class. It takes a double. What does this double value go? It goes to the member variable width. So the argument width goes to the member width. Notice how the standard will start to make sense, the naming standard, naming convention. You're gonna notice that it will start making sense more and more as we go throughout the course. The argument width will be assigned to the member width. Imagine this method a little complicated and it has like 1,000 lines of code. And then when you're looking at one line and you read width, you start wondering, oh, well, which width is this? Is it the member width or the argument width? Is it the width that came from outside the class, or is it the data hidden in the class. So the naming convention is very important. Right now, I can tell right away, whenever I see this variable throughout my code, I can tell that this value came from outside the class, and this value is the one reserved in class. So as simple as this method does this responsibility and only this responsibility as it's supposed to. Then I have another one that is called set height, and this also takes a double height, and then the m height gets assigned whatever the argument height is, semicolon. Then I have a method, another one, we have 5 total, that returns the width. So get, or actually rectangle, colon, width, get width. It doesn't receive anything, but it returns width, the member width. Const. We need to add const. So notice with const, if I say member width equals 10, it's gonna throw an error. It's gonna say, hey, you cannot do that. Expression must be modifiable L value. So return another one for get height, and this time we return height, and then finally we have get area. So rectangle get area, it doesn't take anything, it's a const, and it returns width multiplied by height. Is this how they wanted us to do it? Yep. Return width multiplied by height. So I created my class, and then I defined the functions of that class. These are called accessors. They access the private section and return some values. These two, they modify the values. They are called mutators. So accessors and mutators. And you need to know that data hiding is very important when you have private section, public section, and it's always based on your logic, the way you want to hide your data. You might be wondering, sorry, you might be wondering like, hey, why would I want to hide the data inside the class that I create? Again, it goes back to data, to you being the user of your own classes. It might seem you're putting a lot of effort to hide the data from yourself, but it's gonna be worth it. In the industry, the classes you create will be used maybe by your coworkers or yourself. So by hiding the class data and allowing it to be accessed only through these defined methods, you can ensure that the class will operate the way you intended, the way the writer or the programmer that created the class intended. If you provide everything public, then every outsider that creates an instance of that class will use everything the way they want. But by doing it through this design, using accessors and mutators, you will allow outsiders to the private data using your way, not their way. For example, get width. Get width will return private data the way the programmer intended to return. Here, I can write whatever I want, right? And then either return this or that or something else based on the logic of the writer or the author of the class. For example, get bank account. Well, get bank account, give me the password. Give me the password, I will check it, and if it is authenticated, then I will return the bank account info, right? If there was no data hiding, then everybody can get the bank account info. But with data hiding, I'm allowing, when I write a class and I use data hiding, I allow outsiders access to sensitive information, but my way. So now that we created this class, let's go ahead and create an instance of that class. I'm gonna go ahead and collapse all bodies. Then I'm gonna go to my main. The fact that I created the class above main and defined it allows me to create a class similar to functions. It's the compiler goes top to bottom in each file. If the compiler at this line is aware of a class called rectangle, then it's going to allow me to create an instance. If the definition or main was above the class, then it's not going to allow me to create the instance class. I'm going to call it L box and L for local. Local to main. This is local. This didn't come from outside, and it's not a member variable. It's a local variable to this scope. Yeah, so here, this is similar to the house I drew here. I have a blueprint, which is the class, and then I created one instance of it. I can create another instance of it. I can create as many as I want instances. And all these instances are similar. They are like a twins, identical. But this box has its own data and methods. This box has its own copy of the data and the method, and so on and so forth. They do not share the same data. Every box in front of us has its own width, own height, own method, sorry. But they are twins. Now I'm on topic, page 732, accessing an object's member. Now that I created this instance, I can say, hey, Albox, similar to the string class. Remember how you call length method? I click dot, and then dot will open the capsule for me. It will show me what's in that object. Only the public section. No outsider has access to a private section. No one has access to private section. Nothing at all, except few cases, but we will go later. We speak about it later. So for now, notice I have get area, get height, get width, set height, set width. I would like to set width, and I'm going to say it's 10 or 12.7. Then I'm going to say, hey, Albox, I would like to set height. And the height, I would like it to be 4.8. Then I'm going to say, for example, let's see out Albox dot get width, and then get height. And finally, I'm gonna say see out, hey Albox, get area. And I'm gonna run. So this is my humble program. I created a class, and then I created an instance of that class. I gave it some data through the mutators, and then I used the accessors to get the info back. So notice get width 12.7, get height 4.8, get area is height multiplied by width. If I run again, notice, and I can hover my mouse on the object. So this is my object. See how it tells me the info. I can expand on this. I can see width is 12.6 and width is 4.8. 8. And that's basically Visual Studio allowing me to see through the code. And then we go all the way to topic. They teach us about pointers to objects. Topic, it doesn't have a number, but it's on page 738. They are telling you in a brief that, hey, you can also use pointers to objects. So the same way I used an object, I can say, hey, I would like rectangle pointer L box ptr. So just like an integer pointer, box pointer, this data type carries what value? In integer pointers, an integer pointer carries the address of an integer. So the memory, there is an existing integer, and the pointer can carry the memory address of that integer as if it's pointing to it. That's why it's called pointer. It's pointing to an integer. So this rectangle pointer points to an integer. Right now, it's nothing. It has null in it. Remember, the default to start with is null pointer. Then I can say albox ptr equals give me a reference of albox. Now this pointer is carrying the memory address of the box that I just created. So I can tell cout, I can tell my pointer albox ptr using the arrow. No, the arrow is equivalent to the dot. The dot is for an object, whole object. Arrow is for pointers. So notice how I accessed the value that the pointer is pointing to. This pointer is pointing to this box. So I was able, through using the pointer, to access the data in the value that the pointer is pointing to. And it has all these public area. For example, I'm gonna say, get me the width, and they're gonna be eventually the same value. The width of the box is the same. We're gonna display here because this pointer points to the same box. So now go, and it's gonna tell me 12.7. I can create another box. I can create another box and give it a different value. And I'm gonna show you how they are different. So albox 2, albox 2. Now I'm gonna stop here, run. So this is one instance, one house, if you want to think about it. This is a pointer to the house, to the first house, and then I have a second house. Oh, it happened that I gave them the same value, but I wanted to give them different values. For example, 17 by 18. So now notice if I hover my mouse at Lbox, it has these values, 12.7, 4.8. When I hover my mouse at Lbox 2, it has different values because every instance has its own copy. Then they go over dynamic allocated memory, but we didn't cover it yet. We're gonna cover it after test 1. So once we cover what is dynamically allocated memory and pointers, then we're gonna dynamically allocate memory for classes. Then they go on topic 13.4, why have private members, which is why hiding our data. We just explained hiding the data is very important. The concept in the book says, in object-oriented programming, an object should protect its important data by making it private and providing a public interface to access that data. So this here, the accessors, is the public interface for the private section. This section is a public interface for any outsider that would like to access the private or the sensitive info. For example, in set widths, Although it's a mutator, but I can still restrict some stuff. For example, any outsider that calls me, right now I'm in this scope, I behave or act as I know nothing about the outside world. I'm only within this scope. I receive this, I return this, and I do a task. I set width. So inside this scope, I can allow stuff and deny stuff based on my logic, based on the author definition. For example, I can say if a width is negative, I don't want to set it. I don't want to do anything. Maybe I want to send a signal. Maybe I want to display an error on the screen, but I control the public interface. I as a class provide a public interface to the outside world and I manage it. So for example, here I'm gonna say if it is less than 0, I'm gonna see out invalid number. When I say invalid number, I zero it. I say it's equals to 0. Or maybe I can exit the system. Exit failure. Maybe bigger error. Otherwise, I just set and do nothing. Let's go test it. So in set width, I'm gonna pass it -1 and rerun. See, it closed right away. So I'm gonna run it again. I'm gonna step into using F11. I'm in it. Is it true? Yes, it's true. Okay, see out, error, invalid number. Exit the program. So I need to stop the program. Or I can just zero it out. Or maybe 1, you know, instead of just closing the program. So now, if I hover my mouse at Lbox, although I sent -1, the outsider word sent -1, but the box set it to, how come it set it to -1? Oh, because this needs to be in an else statement instead of, actually I can put it above it. This way, if it's positive or 0, will be set anyway. So set it anyway. In case it was -0, then set it to 0. So now if I run again and I hover my mouse, I'm gonna see that it's 0. Although that I passed -1, but it's 0 because I control. Then we go to topic 13.5 says separating class specification from implementation. So what they are trying to say is in the field, you're gonna see this in one file, the class and the prototype of it in one file, and then the functions are in a different file, and they are called header file and source file. So if I go ahead here and I say right click at header file, add new item, and I need a CPP file, oh sorry, a header file. Header files, right? I need a header file.h that has only the class. What did we call it? We called it that. Not remove. I want to rename. I'm going to call it rectangle.h. Then I'm going to go to main. I'm going to copy this, actually cut this, go back here. I don't need that. I included rectangle. Then I'm gonna go ahead to my source file and say add a new item. This time I need a CPP. They have to match. CPP file and header file for one class have to have their name identical and equal to the class name. So the file is rectangle, the class is rectangle, then the header is rectangle.h, and the CPP file is rectangle.cpp. Rectangle.cpp. Add. Now I have the source file. If I go back to my main and grab all these, cut, put them in rectangle. Now in the CPP, in the header file, I don't have to do anything else. This is it. This is the header file. This is the blueprint, more or less. This is the interface. It's called interface. Class interface means it's just an info what the class has in the private section and what the class has in the public section, but it doesn't have info exactly what each function does. It's just declaration of stuff, prototype. This class has this private, these members, this public, these functions, point. That's the declaration. Then the CPP has the bodies of all the member methods or member functions. The CPP needs to know about the header file. The header file doesn't need to know about anything, but the CPP needs to know about the header file. So include rectangle, rectangle.h. Notice if I open the rectangle, this bracket, it shows me all the stuff from the language, the CPP language that came with it. However, if I open double quotations, it opens the stuff that I added. My Visual Studio added this folder. When I built the program on x64, I created this folder, and then I created this file. I included. Now that I included it, all these methods know what I'm talking about. Oh, okay, you're saying rectangle set width. Oh, we know what you're talking about. Oh, set height, we know what you are talking about. So now they know. However, main still doesn't know. I told main, hey, I need a rectangle, but main says, I don't know what you're talking about. We don't have a built-in rectangle. So I go ahead and tell main, no, it's not built in. I wrote rectangle. Then main goes like, oh, okay, I see it now. I know what's up. Oh, box, okay, set width, set height, etc. So this is the separation between specification and implementation. The header file is the specification. Here you're specifying. In the CPP file, here you are implementing. Main is the outside word that is using or exercising or demonstrating this class. Main is not defining anything in this class. It's just using it. It created an instance of it and experimented it and displayed stuff, got stuff, set stuff, etc. Cool. Let me know if you have any questions. You do not have to have it in this format in this course. But when you go to the industry in the field, everything is going to be in this structure. Header files are in header files, then CPP files will be in CPP files, and then some files are using them, including the header file. They include the header file, and then they use the class. This is one way. Another way is called inline. This is one way, and this is the most popular way. There is another way to define these by actually putting them inside the class. So right away, for example, I'm going to grab this. Cout is not known. Why? Because I have to include IOStream. Just like I do in main. Remember how in main you cannot use the cout without the IOStream without even using namespace std. Now it's gonna know about them. So now this file, the CPP file, rectangle.cpp, knows where its definition is and which library to use for input and output stream and under which namespace. So now we are free, we are error free. If I run, we go back to where we were before I moved them to invalid number, so now it's 0. 4.8 state as is, and I zeroed out both in that example. So if I go back to main, box2 set width is 17. Why it was 0? Oh, well, I didn't display it. I displayed 0 here. I displayed 0 here. Okay, I see. So, yeah, what I was trying to say is grab, let's spin this, and let's spin main, and then close all but pinned. If I go now to the CPP and grab, for example, this set width, copy, copy, copy. I go back to header. See this set width? I could have defined it right away. So instead of making it a prototype, I can remove the semicolon, and then add my body. It takes a double, give it a name. So now it's set. This way is called inline member function. This is an inline member function. What's the problem and what's the advantage of this? The advantage of this is having everything in one file, the body and the definition, right? Earlier, I had in the previous structure, I had the prototypes in here and then the definitions in here. Now I can get rid of this. Why? Because now it's an inline function. It's defined in the class. This is the advantage. Everything is in one file. The advantage is reducing number of files, I guess. Now the disadvantage is, you see this function, it has a size. Under the hood, the system needs to store it somewhere. Also, it has its own copy of stuff. It receives the double, and the double is 8 bytes. It has other info under the hood. Its name, what return type, all this info need to be stored somewhere. So, and it has order of instructions or execution also need to be stored. Everything, function has a big size. So the disadvantage in here is every time I create an object, I'm creating an extra bigger object. So it depends on your logic of your software. If you have a class that you create a lot of instances, then you better not have it inline. Because every time you create an instance, you're adding extra size to the system. However, if you have a class that you barely use, like maybe you created one instance for the entire system. For example, class for antenna, right? You have a software or a robot and it has one antenna. You don't have 1500 antennas. You have one antenna. So there is a class written just for one antenna to create an instance of that class and use it on one antenna. So since you're only creating one instance of that class, you don't care. You don't care for that extra byte. But if you have a class that you use, for example, a record in the database, you have a blueprint that goes like this. Every record is called a record and it has 5 columns. First column is this name, this type. Second column is this name, this type. And then you have 50 billion records like Google. Car, electric car, boom. How many records we have? Come on, come on, come on, come on. I don't see it. Oh, it didn't tell me how many records. Anyway, we have 50 million records. So they have a class that defines a record. And then these are instances of that blueprint. Everything, everything I see in front of me is an instance. A record has, I don't know, image, title, info, links, etc. So again, back to the point, if you have a class that you use and create a lot of instances, do not do it inline, because every instance you create, you're adding extra weight to the system. If you do it the regular way, the way we did it, the normal way, like this, and then we put it back here, then using this way, copy, then with this way, or the system, when you create an instance, it doesn't grab a copy of the function right away. However, when you call that function, then it refers to the CPP. It refers because the CPP is saying, hey, I'm defining that set width. So when someone calls set width, the compiler will point you to this body and execute it top to bottom. So so the compiler or the program will only know about this once someone calls it. And it will be pointed to it, not carrying it in its instance. Okay, so this is what inline functions performance is. Then we go to the topic constructors. Constructors are methods plural, that get called first thing first. Once you create this instance, a constructor constructs this instance for you. Once you create this instance, the first thing that gets called is a constructor. If you do not provide a constructor like I just did here, I didn't provide any constructor, then the compiler will provide a default one for you. It's called default constructor, and it will fill all the variables, member variables with default values. I'll show you. I'm gonna stop here and then run. Ready? Look, I created an instance and I didn't do anything. If I hover my mouse, I'm gonna see that mWidth has negative 9.5. Then mHeight has also negative. This is the default value for a double data type. Anytime you create a data type without giving it a value, this would be the default value. So when I created this instance, there was a default constructor that constructed my instance and gave default values to all the member variables. That's because I didn't provide my default constructor. The compiler did it for me. So what the book is trying to explain at this topic is we have constructors and we can write our own constructors. Constructors always have the same name like the class. Since this doesn't take any input, then it is the default constructor. If this takes an input, then it is an overloaded constructor. So now I'm going to say this takes two doubles. So this is default, takes nothing from the outside, and this is overloaded, takes both values from the outside. For example, main might call or might create an instance of that class and provide the values. Meaning, main is going to say rectangle lbox 1, 5. 1 for width, 5 for the height. Similar to when you create vector. Remember when you create vector, you can give it the values right away, or you can just push them back at later point. So back to the header file. I provided the prototypes for the constructors. One is default and one is overloaded. It says, hey, I can't find a definition for it. Okay, well, we go to CPP and I go similar fashion, similar structure. Constructors go just by the name. So the class is rectangle, colon, rectangle. Now I'm at the default constructor. Then I can say, okay, if any outsider creates an instance of this class without providing any values, I would like mWidth to be 0, And I would like height to also be 0 as well. Now, when I run my code, you see how earlier I showed you it had junk or default value for double 9 minus 9.2, etc. Now, when I created, it's zeroed out. I provided the default constructor instead of the compiler, and I provided the default values instead of the compiler. And here they are. As a matter of fact, I can click F11 and now I'm in the default constructor. I can set values. I can do a lot of things in the default constructor. It's constructor for the object. For example, if we go back to the antenna example, when the system starts, creates the instance antenna, maybe I should establish the connection, not just set values. Set values, establish connection, do the handshaking, report back, log to a file, what's happening, time, date, errors, anything that is unusual. I can do a lot of things in the constructor. Initialize a connection. This is the default constructor. Then we have the overloaded constructor. So I'm gonna copy this. Then I'm gonna tell the system, there is a constructor that takes double A width, double A height. And I would like the argument width to be set to the member width and the argument height to be set to the member height. Then if I go back to main, if I run it again, the fact that main did not give it values, it will hit in the default constructor. However, anytime someone creates a box and give it values, then I will get hit in the overloaded constructor. If I click F11, notice I'm not in the default constructor because I received values. When I go in, I'm going to see 1, and then I'm going to see 5. 1 will go to the width, 5 will go to the height, see the junk value, so I'm overriding the junk value. Now the member height is now 5. When I move back to the outside world and hover my mouse at L box, I'm going to see that it is 1 and 5. So the outside world had access to the data, but the way the class is defining it, not the way the outside world is. The rectangle said the first item is for width, the second item for height. So from the outside world, I cannot control that. I can't say, hey, I want the second value to be the width. No, it's not my way. It's the class's way. You provide values. The first one is going to width. The second one is going to height. Nobody can control. Nobody can change that fact. So data hiding is important. And we allow access to the data using our accessors and mutators the way we define it. So these are constructors. If you have any questions about it, let me know. Default constructor and overloaded constructors. I can have a constructor that takes only one double and then 0 the width. You need to be careful. For example, there is a big logical error here. What is the logical error here? I'm going to give you like 5 seconds to guess. If you guessed, you're smart. If you didn't guess, you're also smart. You're just maybe don't know about it yet. So the problem here is if I say cout L box 3 dot get area, it's gonna return junk. Oh, well, it's not gonna return junk. It's not gonna return junk because area returns the member variables multiplied by each other. However, if I had, for example, go back to rectangle, if I had double M area, right? And then area M area equals this, right? M area equals this, and return M area. Oh yeah, because it's const. Sure. Okay. Never mind. But imagine having it like this. Then I would have a problem in the constructor. Anytime I receive two values, I need to recompute area. Because in this example, I only set width and height. So anytime if someone calls get area right after this line, area did not get computed yet in that case. But never mind. Maybe it was a bad example to explain for that case. We will see that case. My point was watch out for stale data. Anytime you set one member, you need to update any member variables that count or depend on your change. You need to trigger an update for all member variables. Then we go to the topic destructors. Destructors are the opposite of constructors. So the same way we said the first thing that gets created, that gets called is a constructor. A destructor is the last thing that gets called. This object right here is local to this scope. So when this scope ends, this variable and all local variables get destroyed. So in classes, some or most of the time you need a destructor. For example, back to the antenna example, if in the constructor I establish a connection, then in the destructor I need to disconnect the connection. I need to shut down maybe some systems. So let's learn how to write a destructor. I go to the header file and I add, similar to constructor, it has the same name as the class, but it has this icon in front of it. This icon is the key next to the 1 digit on the keyboard. So you see where the 1 is, next to it to the left, you click shift and that key. Hyphen, I think it's called. So hyphen rectangle. This is now my destructor. I go ahead and define it. Let's remove what I did here. So done. Collapse. Go ahead and say rectangle class. I need hyphen rectangle. See out. Goodbye. And anything I need. Disconnect, shut down, turn off some lights, whatever I need to do. I'm going to set a breakpoint here. I'm going to run my program. Now notice I created an instance, no hits, no hits, no hits. Once I reach the end of the scope, I get a hit. Not yet. Now one of those instances is getting a hit. How many objects I had? I had maybe like 3 instances. I had box 2. I had box 3. So now first hit, second hit for the second instance, third hit for the third instance, and the system shut down. So the destructor gets executed last thing. First thing that gets executed is the constructor. Last thing that gets executed is destructor. Constructor gets executed when we create the instance, any line. Doesn't have to be at the beginning of the scope, at the line, at the statement. Here, the constructor gets called. Here, the constructor for this instance gets called. Here, the constructor of this instance gets called. At the end of the scope, all local variables get destroyed. So the destructor for all local variables will get called sequentially. From top to bottom, first constructor, second constructor, third constructor, then the destructor from bottom up. First, we destroy box 2, then we destroy box 3, then we destroy box, just L box. So this is the destructor. If you have any questions. Then the topic speaks about passing values to the constructor, which we did. Then the structures, topic 13.9. Then they speak about overloading constructors. I think we need to go over function overloading. Function overloading really quick. Function overloading means in my system, for example, let's say I have get sum. So int get sum function takes two ints. Let's return it as a double to have a better example. I have a method that takes two ints and return their sum. Then I define it. I say double get sum takes int L1, A1, sorry, int A2, and then it returns A1 plus A2. Simple. This is one version of the method. I cannot have the same name. I can't have another function with the same name, but I can overload this. A function is overloaded when it has different input parameters, and different means different type and different count. For example, double. Another one, for example, takes only maybe takes character, char. So now I'm overloading these methods. It's telling me, hey, I can't find definition for these. Okay, I'm gonna provide a definition. Double, get sum takes double, and another one for characters. Character. Now function overloaded or overloading means if I call, forget about classes. If I call cout get sum and I give it two integers, then one version will be called, the version that receives integers. However, if I call it with double, then the version for double will be called. And if I call it with characters, then the version for characters will be called. So I'm gonna breakpoint in here and in here and in here. Notice when I call it with two integers, then the version with two integers gets called. And if I call it with doubles, then the version for doubles will get called. If I call it with characters, then the version with characters will be called. So function overloading means functions with the same name but different input parameter. Okay, so then the book tries to say in this topic that you can overload constructors. You can have a constructor that receives doubles. You can have a constructor that receives integers. You can have constructor that receive characters, just like you overload functions. Let me stop here. I think this is enough, unless well, we're gonna have more about classes in future chapters. So the only topic left is array of objects. But as an introduction to classes, I think you're good. For only arrays of character objects. Don't worry about it for now, just so we can get ready for the test. Next chapter is chapter 14, more about classes. We're gonna go over a lot of arrays of objects. So for this we are done. Good luck for the test.